Good evening, happy Monday, and happy Pi Day. Welcome to tonight's video. We're going to focus tonight on slope. First off, let's start off looking at our glossary. We have two words that we're going to want to define tonight, and those two words are parallel and perpendicular. Parallel are two lines with the same slope but different y-intercepts. These lines never touch. Perpendiculars are two lines whose intersection forms a 90-degree angle, and perpendicular lines have what we call negative reciprocal slopes or opposite reciprocal slopes. I'll give you a minute to pause the video and make sure you get those vocabulary words down. Alright, so now let's look at what we're going to be focusing on tonight, and that's going to be slope. Slope is something that we have talked about earlier in the year, so it's something you guys are familiar with. Remember, the other name for slope that we have is rate of change. And we have a formula for the slope or rate of change, and that is m equals y2 minus y1 over x2 minus x1. That's a formula we've used quite a bit in this class. Also want to remind you guys about slope-intercept form. That's when we have y equals mx plus b. If you recall, m is what represents the slope of our equation, and b is going to represent our y-intercept. And remember, our y-intercept is where the graph crosses the y-axis. So we have a couple different possibilities for slope. Slope can be positive, negative, undefined, or zero. If we have a line like this example here, where it's slanting up and to the right, we say that that has a positive slope. Our next line that's slanting down and to the right, we're going to say has a negative slope. If we have a line that just goes straight across here horizontally, we're going to say that that has a slope of 0. And then finally we have a straight up and down vertical line, and we say that a vertical line is a slope that has an undefined slope. Alright, now we want to take slope a little bit further. We're going to look at slope in dealing with parallel and perpendicular lines, the two words that we defined in our glossary just a little bit ago. So we say that two lines are parallel if and only if they have slopes that are the same. That means they're going to look exactly the same. If the slope of one line is 3, the slope of the other line is also going to be 3. We also have perpendicular lines. Perpendicular lines, if you remember in our definition, form 90-degree angles. And we say that two lines are perpendicular if and only if they have slopes that are opposite reciprocals. And what that means is if you take a number and invert it, it's going to be the reciprocal. So for example, if I have a slope of 2/3, my reciprocal would be 3/2. Now note that it's just not the reciprocal that has to be true, that it has to be the opposite reciprocal. So if we wanted a slope that was perpendicular to 2/3, we would want one that was negative 3/2. We flip the fraction over and we change the sign. For example, if we had a slope of a line that was -4 and we wanted to write a slope that was perpendicular to that, we would have to flip it over. Now, -4 is a whole number, but we can make it as a fraction by putting it over 1. So now if we flip it, it becomes 1/4. And note, it's already negative, so the opposite of a negative is a positive, so we would want a slope that was 1/4. Now, let's look at example 1. We are asked to find the equation of a line that goes through the point -2, 0, and that is parallel to y equals 3/2 x plus 1. If you remember, this is in slope-intercept form, so we know that the slope is going to be right here, 3/2. So the slope of our original line is 3/2. Now, we want a new equation that is parallel to that. If we remember up above, parallel lines have the same slope. So that means my slope for my new line is also going to be 3/2. Now, I don't know anything else about that line yet, So I'm just going to write that I know my new equation is going to look something like this. Y equals 3/2, because we're just pulling that slope that we just found, x plus b, because I don't know what my new y-intercept is going to be yet. However, we are given a point, -2, 0, and we know that that point has to be on this line. So what we're going to do is we're going to plug that point in here and solve for our y-intercept. So, in this ordered pair, y is 0, so I'm going to put in 0 there, and x is going to be -2. So, just to recap, all I did is I took this ordered pair and replaced the appropriate variables in this equation. So, now I just have to solve for b. So I'm going to have 0 on the left. 3/2 times a -2 is going to give us a -3. So I have 0 equals -3 plus b. To solve for b, I would need to add 3 to both sides. And I find that b is equal to 3. Now I have one last thing to do to make this equation. I have to take this b, and I have to plug it back in up here. So my final equation is going to be y equals 3/2 x plus 3. And that is my equation for a line that is parallel to y equals 3/2 x plus 1. Notice it has the same slope, but it has different y-intercepts. So these are going to be two lines that never touch. Now, in example 2, we're asked to find the equation of a line that passes through the point 0, -3, that is perpendicular to the line passing through the points 3, 4, and 4, 2. Now, notice this time they don't give us an equation, so it's left to us to find our own slope. So, our original line passes through these 2 points. So what we need to do is plug those 2 points in to our slope formula that we had above. So, m is going to be equal to y2 minus y1, and I'm pulling these from these ordered pairs up here, over x2 minus x1. So I simplify. 2 minus 4 is -2, and 4 minus 3 is 1. And this simplifies down to -2. Now for my new line, I need the opposite reciprocal of that. So if my slope for my original line is -2, as a fraction that would be -2 over 1. To get the opposite reciprocal, I have to flip it over and change the sign. So I flip -2 over 1 to 1 over 2, and since it was negative, I made it positive. And now I'm going to proceed very similar to the last example. So I have my new slope, so I'm going to plug that in. Y equals 1/2 x plus b. I don't know what the y-intercept is yet, but I know that I have a point 0, -3 that goes through the new line. So just like we did above, I'm going to plug that in to this formula. So I have -3 as my y value, and 0 as my x value, plus b. So I'm going to simplify. -3 equals 1/2 times 0 is 0, plus b. Now we know that anything plus 0 is what we started with, so I'm going to have that -3 equals b. Now to finally put this together and write our new equation, we're going to start out with y equals, remember our slope from our new line is 1/2, which was the negative reciprocal of our original, x plus, we just found b was -3. Now, we have plus a negative. A simpler way to write that is to simply write -3. So I'm going to rewrite it one more time over to the right. We're going to have y equals 1/2 x minus 3. And that's my final answer. Alright, so that wraps up slope. Make sure that you have this page completed for when you come into class tomorrow. Have a good night.